I'm Andy Greenfield. I'm an honorary research fellow at the University of Oxford in the UK, and I've been working with a number of organisations concerning matters of genetic technology. Many human diseases are caused by small changes to genes called mutations, and these are usually found on the chromosomes that we have in the nuclei of our cells. But some diseases are caused by mutations to a special piece of DNA called mitochondrial DNA. And some women are at risk of transmitting mitochondrial DNA mutations to their offspring. If this transmission happens, these children can get very devastating diseases which are life-limiting. And so mitochondrial donation is a methodology which aims to prevent or at least reduce the risk of transmitting those mutations from mother to children. So these diseases can affect any number of tissues in the body. Most commonly they affect the nervous system and the muscle, and so they can lead to a whole series of abnormalities varying in how severe they are, and in the most severe cases they will lead to the death of a child. These women do have options, so any woman who's at risk of transmitting these diseases has options. One of them, of course, is to remain childless. One of them is to adopt. One of them also is to have an egg donor, because they could use a healthy egg donor who doesn't have mitochondrial disease, and that way they could have children who are free of that disease. But in that case, they wouldn't be related to the children. If they want to be related to the child, then the two options are either embryo testing or mitochondrial donation. So why might a woman choose this? Well, I guess that's a bit like asking the question, why does anyone have children? For the vast majority of human history and prehistory, the only children that we ever had were those children to whom we were genetically related. So it's important to understand there's nothing unusual in this request. When they want to have children, they want those children to be healthy, they do want to be related to them, but in that sense, they want what most other human beings on the planet have access to naturally. It's challenging for the scientists who have developed the technique, because they have to now use this technique with patients for the first time. It's challenging for also the clinicians who have to decide which women might benefit from mitochondrial donation. And finally, it's challenging for the regulators, because they've never regulated this process before, and they need to learn so much about what the pitfalls are and the risks are. So the whole aim of this technology is to prevent mum's mitochondrial DNA from being inherited by her children, because it's disease causing. And so one concern that everyone has had is that there's a possibility that even though much of that DNA is replaced and comes from a donor instead, that her DNA may make some kind of comeback. And this is a process that we know as reversion. And in reversion, it may be that a larger proportion of the child's mitochondrial DNA will come from mum and not the donor. And this, of course, is then a risk of disease. And so it's one uncertainty is what is the likelihood of this happening? That's somewhat unclear. But fortunately, of all of the children that were born in Newcastle that were reported last year in the UK, none of them seem to have reversion. Mitochondrial donation, both in the research phase, which was critical in its development, and also in the treatment phase, requires egg donation. And those eggs are a vital source of healthy mitochondria. But egg donation doesn't come without risks to the woman who donates. Her ovaries must be stimulated in order to generate enough eggs to then be collected. And that hormonal stimulation does come with some risk to her. For that reason, it's really important that we regulate mitochondrial donation tightly. And in the UK, that is done by the Human Fertilisation and Embryology Authority, or the HFEA, which is the national regulator. And that means that we can institute guidelines of best practice in terms of egg collection to protect those people who are prepared to do it, because it is an altruistic donation. It's a gift. So mitochondrial donation in the research phase did require experimenting on embryos, which means that embryos were destroyed, and they will be destroyed as we continue to research and refine these methodologies. It's true also that with one of the techniques, 2 embryos are required to generate 1 embryo for use. So it's 2 in and 1 out. That requires embryo destruction. Some people are concerned about embryo destruction. The only way to think about this is that in our society, both in the UK and also in Sweden, we have legal human embryo research. So we have come to a decision as a society that human embryos can be used in experimentation because of the potential benefits. Some people are concerned that the use of mitochondrial donation might create some kind of slippery slope, whereby other technologies that we could use to intervene in human reproduction become more likely. For example, might we start to use technologies such as genome editing to alter the characteristics of children? Might we ultimately generate what some people call designer babies? But again, I think that the regulation that we have surrounding these technologies should ensure that they are never used in a trivial fashion or for cosmetic reasons. Some people think that mitochondrial donation is rather similar to reproductive cloning, and there are surface similarities. So in mitochondrial donation, nuclei are moved from one egg over to another egg, a donor egg. And in somatic cell nuclear transfer, i.e. reproductive cloning, a cell nucleus is moved from a somatic cell, like a skin cell, also into an egg. But in that case, reproductive cloning, there is only one parent. That's why we call it cloning. There aren't 2 parents. In the case of mitochondrial donation, there are 2 parents. It's sexual reproduction. The only difference is that the mitochondrial DNA comes from that 3rd person. Why it's so bloody cold. I think we'll look back and wonder why we didn't talk more about these topics. Why we didn't talk more about how important reproduction is to most human beings. How reproduction matters so much to people. And the subject matter of ethics, if there is a subject matter to ethics, is what matters. And clearly reproduction matters enormously to people. So to somehow trivialize the desire to reproduce as if it was like the desire for a handbag, I think is to completely misunderstand how central the desire to reproduce is in most humans. And so we need to talk more about that urge to reproduce, more about whether as a society we should support those individuals who wish to reproduce but need our support and help to do so. We need to talk about whether technologies which help individuals to reproduce should be used and under what circumstances they should be used, because these technologies are coming our way. They're not going to go away. There's going to be more and more of these technologies. So how should we understand their use and how they can add value to human lives?